This is exercise 626. This has to do with the standard normal distribution that we talked about previously. And these are just some problems that I did not go over that you will be expected to know in preparation for your test. The problems that we did prior to this involving the standard normal distribution, we were looking for the probabilities. On these problems, we're given the probabilities and they want us to find what we call the z-value or the z-score that is associated with this particular probability. So for these problems, instead of looking at the first column and the first row and going to find the probability or the area under the curve, what we're going to have to do is look inside the table and look at the area and find the associated z-score for that particular area. So let's look at the first problem. Again, this is exercise 626. I did not do I'm not doing all of the problems. I just picked 3 of them so that you can get a sense of what needs to happen in order to find the associated z-score. So let's look at B. They're asking us to find the probability that z is greater than or equal to z sub alpha, but the probability under the curve for this area has to be 0.05. Well, let's look at this. Remember, when we're dealing with probabilities of continuous random variables, we're always looking for the area under the curve. And of course, the normal distribution is a continuous, involves a continuous random variable. So we're looking for a z sub alpha where the probability that the z-score or the z-value is greater than that score is 0.05. First of all, I know that the probability is very small. And so if I'm looking for a z-value that is greater than z sub alpha, I know that that value has to be at the tail end. Since the whole area under the curve has to equal 1, because we're talking about a probability distribution or a probability density, I should say, then I know that the rest of this here has to be 0.95. So remember, the table, the normal distribution table, gives us the area under the curve that's to the left of the z-score. So when I'm looking at the table, those probabilities that are giving me the area that's inside here. So the alpha that I am looking for is going to be 0.95, which tells me I need to find the z-score that's associated with 0.95 as the probability. So in order to do this, we are going to have to go inside of our table and we will look for 0.95. You will see that 0.95 really involves 2 values. 0.95 is in the middle, exactly in the middle of these 2 values. So I have a value that's associated with, this is 0 or 1.6. This is 0.04. This is 0.05. So I know that the z-score that I'm looking for has to be in the middle or the midpoint between 1.64 and 1.65. So how do I get that midpoint? To find the midpoint, you add the two, 1.64 plus 1.65, and divide that by 2. You end up with 1.645. So the z-score that's associated with 0.95 is equal to 1.645. Now let's look at E. With E, again, we're trying to find the z sub alpha that's associated with the probability that's associated with the area under the curve that is 0.01. But this time we're looking at, for the z-score, where the probability is less than z. Again, I'm looking at 0.01, and I know that that's a very small probability. So if we're looking at the probability that z is less than z sub alpha, I know that that score is going to be on the tail left. That probability is going to be 0.01. But just like the other problem, I know that if that probability is 0.01, I know that the probability of everything to the right is going to be 0.99. Again, because the probability under the curve has to total 1. Recall that our probability distribution, or our standard normal distribution table, only gives us probabilities that are to the left of the z-score. And notice that this number here, the z sub alpha that we're looking for, is less than 0 because it's to the left of 0 on the number line. So those are two things that we need to keep in, those are two things that we have to remember. Also remember that our standard normal distribution table only gives us positive values. So we're going to have to look at this more closely. Knowing that the normal distribution is symmetric, I know that there's a corresponding z sub alpha, and it will have to be the negative of that. Since z sub alpha I know is negative, I know that to the right of 0, I'm going to have negative z sub alpha, and that's going to be the same area that we're looking for. I can find this value because it's positive. So I can find that value on our normal distribution table. And so let's look. So I know that this area right here is 0.01. So that means the area to the left has to be 0.99. So the alpha that we're looking for is going to be 0.99. And we want to find the z-score that's associated with that alpha. To do this, again, we go to our table, and we're going to look for the closest number to 0.99. And as I'm looking, I see a few numbers. Let's compare them. You have 0.9898. Okay, that's very close to 0.99. But 0.9901 is even closer. Looking at 0.9904, no, this one right here is the number that we want. That's the closest value that we have. What is the z-score associated with that? It's 2.33. So I know that this value, this is actually negative z sub alpha, is equal to 2.33. Well, we want to figure out what z sub alpha is. Z sub alpha is going to be the negative of that. So z sub alpha is going to be negative 2.33. The last problem, F, is the easiest of them all. They're asking us to find the z sub alpha that's associated with the probability of 2.64. Well, we know that that's not possible because we know that all probabilities must be between 1 and 0. So for F, this is not possible.